Please open in your learning workbook to page 208. We now summarize the log rules we've learned so far, as well as solve two problems from Alex. All right, so here are the log rules. We have the product rule, the quotient rule, and the power rule. All right, so the product rule says when you have a log of a product, you can write that as two logs being added, where the arguments of those two logs were the two things that were being multiplied. The quotient rule says when you have a log of a fraction, of a quotient of division, you can write that as two logs being subtracted, where the first argument is the numerator and the second argument is the denominator. And finally, the third log rule that we learned says when your argument of your log has an exponent, that exponent can be moved to the front of the log as a multiplying factor. Okay, we will now use these three tools to solve problems. Here's the first one. Log base 4 of 5 minus log base 4 of 9 equals log base 4 of blank. And we have to fill in the blank. Okay, so the first thing I notice is I have two logs being subtracted and they have the same base. So that means if I want, I can use this rule, the quotient rule. It says when you have two logs being subtracted and the bases are the same, you can write that as just one log using that base, as long as you change the argument to be the fraction dividing these two values. So we can combine these two logs into one and write them as log base 4 of 5 divided by 9. I'm making a fraction. 5 divided by 9. The right side of my equation does not change. Okay, so now I need to figure out what has to go in this box to make these equal to each other. Well, I hope that's obvious to you. It's 5/9. If you want these to be the same, they both say log base 4 of. This one says 5/9, so this one also needs to say 5/9. And so the value that we need to put in the question mark box is 5/9. Okay, let's do our next one. Log base 7 of blank plus log base 7 of 5 equals log base 7 of 40. This is two logs with the same base being added, so it looks like this top rule here. When you have two logs with the same base being added, you can write them as one log with that base. You just have to multiply the arguments. So this will be log base 7 of the question mark block times 5 equals log base 7 of 40. Okay, so what does the value of the question mark block have to be so that these are equal to each other? They're both log base 7 of, so that means that these arguments need to match. We need for this number and this number to be the same. So that tells us that question mark times 5 equals 40. And if you divide both sides by 5, you get question mark equals 8. So the value of the missing question mark block in this problem is 8. Okay, one more left to go. In this last one, we have negative 4 log base 7 of 3 equals log base 7 of blank. And so we need to find a way to make these look the same. This one has a factor in front of it, negative 4, whereas this one does not. So we need to find a way to get rid of this negative 4. What that means is that we are looking at this third rule here. So we have a factor p in front of our log that we don't want to be there. So how can we move it? We can move it to become the exponent of the argument. So we can write log base 7 of 3 to the negative 4 power as the left-hand side. Okay, so now we have this statement. Log base 7 of this equals log base 7 of that. So if we want these to be equal, that means the value of the question mark block needs to be 3 to the negative 4 power. This and this must be equal to each other. So we can state that the value of the question mark equals 3 to the negative 4th power. Using our intermediate algebra exponent rules, this is the same as 1 over 3 to the 4th power, which is 1 over 81. So our final answer for this problem is the fraction 1 over 81.